Hello, so here's our Math Olympics problem involving trailing zeros. So the question is, how many zeros are there at the end of the product of the first 20 primes or the first 20 prime numbers? So you need to find the first 20 prime numbers and you multiply all these 20 prime numbers. And the question is, how many zeros are there at the end of the product of these 20 primes? Is it A, B, C, D, or E, which is none of the above? First step that we need to do now is we need to understand first what trailing zeros are. A trailing zero at the end of a number means that the number is divisible by 10. So if there is a zero at the end of a number, like a trailing zero, at the very end of the number has a zero, that number is divisible by 10. And what are the factors of 10? The factors of 10 is 2 and 5. So since 10 is 2 times 5, so each trailing zero corresponds to one factor of 2 and one factor of 5. Since 10 is divisible by 2 and 5, so expect that that number with a trailing zero could also have a factor of 2 and a factor of 5. Now when you factor that number that has a trailing zero, so the number of trailing zeros, this is very important, which I want you to remember. The number of trailing zeros, if you are asked how many zeros are there at the very end, is the smaller of the exponents of 2 and 5 in the factorization. So what you need to do is simply look at 2 and look at 5, which are the prime factors, and look at the exponents of 2 and 5, how many there are. And the smallest exponent would be the number of the trailing zeros. So if the smallest exponent is 2 or 3, then there would be 3 trailing zeros. So let's review a prime number since we want to know the first 20 prime numbers. So a prime number is a natural number greater than 1 that has no positive divisors other than 1 and itself. So in other words, it cannot be formed by multiplying two smaller natural numbers. So prime factorization of the product of the first 20 primes. So the first 20 primes are, these are now the first 20 primes. Once you have listed them all, then you need to multiply them all. So 1 times 3 times 5 and so on until you have reached 71 times 71. So each prime appears exactly once. You can multiply all of them and then you can find how many zeros are there at the very end. Or what you can do is, in this product, each prime appears exactly once. Look at the list of the prime numbers there. They only appear once, right? There's no double 19 or double 47. There's just one of them. So it's uniquely one, since they are distinct prime numbers. Remember, we are after 2 and 5, so we need to count the exponents of 2 and 5. The prime 2 appears only once. That means it's 2 to the 1. The exponent of 2 is 1 because it's 2 to the power of 1. It only appears 1. How many times does the 5 appear? 5 appears exactly once. That means the exponent of 5 is also 1, 5 to the power 1. Since both 2 and 5 have the same exponents of 1, thus in the prime factorization of the product, 2 to the 1 times 5 to the 1. The number of trailing zeros, remember the number of the trailing zeros is the minimum of the exponent of 2 and exponent of 5. However, the exponent of 2 is 1, the exponent of 5 is 1. Therefore, the minimum between the two is 1. And we conclude that the number of zeros in that number of the product of the first 20 prime is letter B, 1. There would just be 1 0 at the end of the product of the first 20 primes. How did we get 1? By simply looking at the exponent of 2 and 5. I know you have some questions. Just leave your comments below. And I hope to see you again in my next video.